Hey, it's W5HRO. I'm out here in the garage modifying this grid input the rest of the way and see what this RF choke disconnected here from the rest of the circuit from the grid link resistor to ground. I'll check it and I'm seeing 0.03 nanofarads. And I've checked it, I've calibrated the meter. I've calibrated the meter to work so it's exactly it's zeroed when I've got my finger, because I noticed when I'd wrap my thumb and my fingers around this alligator clip, it would change it a little bit and it was out of zero. So if I do it with a zero now with my hands on it, let me get back where it was. There, and I touch it, it's 0.03 nanofarad, which is exactly 30 picofarad. That's as low as I can get it. And I started out, I had the wire wrapped around here, going down, and I thought that's a little too long. So I decided to drill a hole and I just kind of ran the cable. See, the dielectric, what I did was, that was RG58U I had in there, and it was exactly 16 inches long. That piece where I was seeing the 50 picofarads all by itself, it was RG58U with the strand center conductor. So what I did was I just stripped it all back, took the jacket off of it and everything, and I'm just using the dielectric to go across. And what I'll do is when I eventually get the thing fully working, I'll just disconnect this here and I'll put like a 2 kV doorknob here, or I'll just splice it in the middle or something to DC block it. When I get it all working, if I put a big enough value, it won't restrict the grid drive current. I just have to make it big enough after I get everything working and get the exciter completely tuned. Then I'll do that, and that way it'll DC block. Because what's going to happen is that as you increase the grid drive, that negative grid voltage is going to go down through the cable out the connector. So that's why I want to DC block it in the end. But for right now, I want to make sure a cap's not going to mess up my tuning and everything and getting the thing working. So I don't want any extra voltage division that I don't need unnecessarily. So that's what I'm trying to do right now. I'm trying to get it working, before I put the blocking cap there in the end to isolate the DC. And that's just a safety thing. I don't like having the DC running along the coax. But like I said, I ordered some RG63 coax, which is only about 10 picofarad per foot. So I have 30 picofarads here now total. And then with say I have 2.5 feet of coax, 2 feet of coax would be about 20 pic. So I'm going to have probably about 30 more picofarad in coax. So 30 plus 30 is, because the coax is going to be essentially, the capacitance is in parallel with this. So it's going to be about 50 to 60 picofarads, probably close to 60 picofarads by the time I'm done. And that's as low as I'm going to be able to get it. Hopefully I can tune the end of the coax at the exciter, and that'll take care of it. So we'll see what happens, but let me real quick, I'll show you what I was seeing the other day that was throwing me off, that I thought I had 2,000 picofarads, and I'm like, what? And after I thought about it long enough, I thought, there's no way it would work with 2,000 picofarads, but I realized what was happening was, it's hard to do this with one hand. I'm trying to hold the screwdriver here, put the screw in, and I'm trying to hold the camera at the same time, so I'm one-handed right now. There we go. Now see if I touch it. Look what it does. 2.22, that's 2,220 picofarads, what that is. But it's because this meter puts out a 1 kilohertz test signal, I'm pretty sure. So it's running down through the choke, so it's seeing everything past the choke. When I run the HF signal into it from the exciter, it's going to be isolated. That choke's going to block it, so it's not going to see all that. So that's what I've got it down to now. I've got it down to exactly 30 picofarads on the input, and it was 70, so that's a big improvement. So that's it for now. This is W5HRO modifying the RF grid input at the RF deck here on the 4400.